Hello again, once more. Welcome back to the cellar. This one I'm going to be solving a little bit of a problem with making a little track power indicator. Spoiler alert, this is Leopard Street, so yeah. Hello, once more. Welcome back to the cellar. I'm not standing inside it this time. Today, I'm going to do something a little bit different. I was sort of thinking, what do I do today? Get rid of the cobweb. What do I do today? Running trains, bits and pieces. Do something a little bit different. I'm going to solve a problem I have. Completely. Going to design it, build it, install it. It's something quite simple. It's something that might be useful for other people as well. Let me show you what the problem is. The problem's quite simple. This is my DCC EX unit. Very nice it is, it works quite nicely. Is the power to Leopard Street on or off at the moment? In other words, have we actually got track power? Because we can look around and there are trains, there's nothing moving, so it's not immediately clear. There's little health lights flashing away. The only way to tell is to look at that screen, which says power is off, and to peer under there where there's some LEDs. They're off at the minute. If I turn them on, there you go. Track power is now on. If I come back to over here, what's different? Nothing. So, turn it off again. What I'm going to do today, I'm going to build a track power indicator, which I don't need to fit onto this. I can fit it anywhere, and in practice it's going over here somewhere. Later on I might move them. I may end up drilling some holes in this side and mounting a little panel with some status LEDs, but for now it's going over here somewhere, just probably in this little area here. Something I want an LED that comes on to tell me my track power is working. I've also built this as a little aside. We will have a little look at some of the other bits and pieces on the layout later that have changed. This is for, there's two infrared sensors. If you saw my video on sensors, this is going to hold a little circuit board with an LED pointing down, and then the train will come along here and I'll know the train is there. Yeah, that's for another video. So, let's get to the desk and we'll have a look at how we're going to do this. Okay, so here we are back at the desk, having cleaned the desk off. So what do we got? Well, to start with, what we're going to have is a screw terminal, and that is going to have two wires, DCC in, and that is sort of an AC waveform that does stuff like that. And what I want to do is I want to light an LED up, and I have here a bag of LEDs, and what I'm going to do is I was going to find the green ones, however they're not in that bag, so I'll have to look somewhere else for a green LED. That's by the by. I'll sort that out in a minute. But what we have, I'm just going to draw it out this way like so, make a bit of space, a couple of wires. Now I want to put an LED, and to do an LED I'm going to need a resistor. And we'll look at how I pick that resistor in a minute. And it's going to come down here and it's going to split off and it's going to come down here through an LED. And that's fairly normal. If this was a DC circuit, that would be fine. I'm not going to rectify the voltage. I'm not going to smooth the voltage. I'm just doing it very, very simply. Now, the thing about light emitting diodes, they work as a normal diode. So the only time the current is going to flow is this way. So if up here is positive, down here is negative, current will flow. If instead up here is negative and down here is positive, the other side of the waveform, nothing will flow. In theory, the light will flicker. It's going to be at a high enough frequency, I'm not going to see it. I don't care. I just want an indicator light. What it does mean is the light's brightness is going to be about 50% of what it would normally be, because it's only going to be on about half the time. Thing with LEDs, they will work like this, but what they don't like is a lot of voltage going the other way. So what we're also going to have is a normal diode that way. So when this is positive, current will flow down that way. When it's the other side of the cycle, current can flow that way. Done. So that's going to be a resistor, and I want to know what the current there is. So what's the voltage? Well, I'm feeding this thing on 15 volt. So it's either plus 15 and ground, or effectively minus 15 and ground, but essentially it's 15 volts either there, and ground is at the other one. So I've only ever got a 15 volt drop across there. Right, so what we have is the value of the resistor is equal to the voltage of the supply minus the volt drop across the LED, and we'll have a look at that in a sec, divided by the current that's going to go through the LED. So, okay, well, what have we got? That's 15 volts. LED drops 2.1 with a green LED, so I'm going to call it 2 because I like nice simple numbers. And the current I want through there is 3 milliamps, so 0.0003. Too many zeros. Do that again, 0.003. And what that works out as is it says I want a 4,300 ohm resistor. Ah, well, that is actually a standard resistor value. That'd be brilliant. Have a guess what resistor values I don't have. Yes, that's one of them. So what I need to do is we swap this formula around up here. So it becomes Vs minus VLED over the resistance equals the current. What value resistors have I got? I want it to be similar to that. Now 3 milliamps is about as low as I want to go. So what I want is the resistance to be a bit lower than that. So I'm going to have a look at what's the value I've got. And I've got, so I'm going to come up here, and that is 15 minus 2. And I have got a 3,900 ohm resistor. I hope I should have. And what that's going to give me is about 3.3 milliamps. So that'll do. So what do I need to do? Well, the first thing I need to do is find the appropriate green LED, but we're going to turn this into a circuit. And to do that, I need a piece of stripboard, and I'm going to have to drill a hole in that to mount it with. So I need a drill. I need a screw terminal, which I've got. I need a normal diode, and the diode I'm going to use is one of these, a 1N4001, a rectifier diode. It's a normal diode. It's nothing fancy. It can cope with an amp. I'm putting 3.3 milliamps through it. Don't think I'm going to have a problem. Then, yeah, I need to play with this. I need to find the right ones. So I'm going to find the LED. I'm going to find the resistor out of this box, and then I'm going to be back. Right, I'm searching the magic box I've got upstairs. The green LEDs out of that bag. So I just need to go through here and find the 3K9 resistors. If I can find them. These little boxes, I mean, I've got some resistors I use a lot of. I get through rather a lot of 1K and 10K resistors, so I've actually got bags specifically of those. These are for when I need a weird value. So I got this pack. It's fairly cheap. K5s, yeah. This one I think, I don't know, is eBay or Amazon. It was one or the other. 47 ohm. Don't want that. These are really useful little boxes when you you might need a weird value, but you won't need very many of them. It's just for some sort of experiment. So 3.90. So yeah, resistors come in strange values. The combinations they come in make it quite easy to make pretty much any value you want once you know how to do them. 3K3 is a little bit low. 3K9, here we are. So I want one of those. So I need that one. I'll put all of the rest of these back. The other thing about these boxes of resistors, which is anybody who's ever had one of these boxes will tell you, once you opened it, you'll never get it shut. Yeah, so there's a table on here. I mean, you get the color code and how to read them because they're stripes. So this one here should be an orange. Yeah. Anyway, it's a 3K9 resistor. Yes. I'll put that over there out of the way. I'm going to turn my soldering iron on. And I'm going to get one of these diodes out, which I'm going to need as well. Just need one of them. Come here. I'll take one of those out. That. And diodes have the little symbol on them. It goes that way around. As long as I put the green one in the other way round, we'll be all right. So they have an anode, which is the long leg, and a cathode, which is the short leg. The anode being the side that goes positive. So that's that. They can all go over there out the way. I found some relays, which are quite nice as well. And we look at, well, so how are we going to actually make this? Well, that's going to go in there. There's one thing I do actually need to do before I do this, which is to find my little screwdrivers. If you're ever going to use any of these little connector blocks, this is something that's well worth doing. Just check and make sure they work. I've had any number of these, and I've found various ones of them that don't work. They don't turn properly. That one does. So what we're going to do is we're going to put this somewhere. It'll go in somewhere about that. And we need to actually make this circuit. Now this has gone in. Let's draw this. It'll probably be easier. So if I move this piece of paper out of the way, I'll get some more. What I've got is 3 strips. 3 strips of copper. Well, I've got more. They go this way. I'm going to put that connector block in. So if I grab another pen, the connector block is going to go to there and to there. And it's quite a big thing. It's going to sit over here like this. Now from our circuit, I need to connect both of the diodes. And what I'm actually going to do is I'm going to put the resistor is going to go from there, a resistor like that. Now to do that, I'm going to stand it on its end. I'm going to bend the little wire around like so. And then it can go something like that in the middle. That'll do. And that connects this outer track to this middle track. And then what I'm going to do is I'm going to put the LED there, which will fit in directly. And I'm going to put the other diode in there. Again, I'll stand the diode on its end. So I'm going to do that, bend it round like that. So I've got the resistor there, I've got that diode there, and then long leg positive that way. I've got that there. And that's basically the circuit. As I say, I need to drill a mounting hole in this, so I'm going to do that before I do anything to the board. In fact, what I'm actually going to do is drill 2. And then later I'm going to 3D print, and yeah, that's just what I do. The mounting block for this. So I just need to drill a little hole through here, like so. The board is rather annoyingly fragmenting slightly, but never mind. So that goes in there, that gives me a hole. And I'll do the other end. I'll do from this side, like that. And the beauty of these boards is this is all standard standard dimensions. think it's 2.54 millimeters between each hole, which if you go into old money works out as something. So I'm going to turn my soldering iron on. I'm going to flip this back over and I'm going to start assembling bits of this now. I'm going to put that there. It would help if I turn the soldering iron on. Yeah, anyway, never mind. So that's going to go there. These other components are going to go in, and I can put these in now. So that resistor goes in there, and just splay the legs out a little bit, because that'll stop it falling out. I can put that in there, and again just splay those legs out a little bit, and then that one get it the right way round, because with LEDs it matters, a little bit spaced away just so that it fits better. Going to do that, and now for the third time I'm going to try and turn my soldering iron on. Yes, that worked that time. Right, so I'm going to move all this paper out of the way, because paper and heat is not necessarily a good idea. I've got a light I'm going to turn on, which will help me see what on earth I'm doing. So I've got that, like so. You can see this. I'm going to try and zoom you in a little bit. That one. There we go. As usual, having to play around with my my phone slightly there. So I need to bring this light so I can see what I'm doing. Try and keep this where you can see what I'm doing. And then I'm going to apply a little bit of this liquid flux onto the various joins. And this basically is going to clean, it cleans away any oxidization and stuff that's on the board. Helps the solder flow. And soldering, hopefully, this is going to go a little bit better than the last time I tried videoing soldering, where I was soldering to a board, soldering rails rather, and it didn't work very well. So there we go. Now what I'm going to do is do the LED first. So I'm going to need a bit more of this. Yeah, this is always awkward. I've got one of those helping hand things somewhere, but I can't find it. I think it's in the kitchen. So do that to there. Once the first component's on, it's usually quite simple. So that's there. And that's the first leg of the LED soldered. So that'll do. The LED is the component that's wobbling around, which is not helping. So in we go with that. Why that's not heating onto the circuit board. There we go, done. Typically what you want to do is heat up the board. The idea is you heat the board and the component legs slightly, and then feed the solder in. So if I now get rid of those legs, it just basically makes getting access to the next bit a bit easier. I'm just checking to make sure there's no solder bridging between the two tracks, and there isn't. So here, next up is, make sure that's somewhere you can see this. That will go there. I'll then feed a bit of solder in. Look, that looks good. And can do the same with this leg here. And feed a bit of solder in there as well. And what you find is once it starts to flow, it'll flow onto the joint nicely. Yeah, you want to make sure you get a good contact with it. So get rid of these legs here as well, which are a bit thicker, because I say it's a high value component. And now I do have, I don't know if you can see this here, I do have a tiny little solder bridge, which is a short circuit. So I need to get rid of that. And the way to get rid of it is heat one side up again, no matter which, and just move the soldering iron around. And that's got rid of it. Basically, the solder, it's got a surface tension, so it'll flow a little bit away from some of the joints. If you just get a little bridge like that, that's that leg. Do this leg here. Now I'm going to be doing another version of this at some point. You may have seen in a recent video I have the emergency stop switches, so they are going to be used at some point. That will have its own power state LED, and it'll have other bits and pieces on it as well. However, what I wanted was something that worked quickly, and this will work quickly. I did one of these for Dinglebury, my little N-gauge layout, which I will have to get around to showing at some point, although it doesn't run. It's not operational, and it won't be operational again ever, probably. There's enough bits been robbed from underneath it that I don't think it's ever going to work. Let's just take that down. But it has a little board. That should be for soldering. It has a little board on the side of it, similar to this. It's got an indicator light. There we are. Done. I'm going to test this in a minute before I make the mount for it. It's got an indicator light that comes on when DCC track power is there. It's also got some other ones that come on when the 5 volt and the 12 volt power supply is running. Right, so the next thing I need to do, I've got to do a mount for it. Before I do the mount, I'm going to test it, because testing things is good. So to do that, I'm going to need to make 2 little wire leads that can come off and go into a track feed. I'm going to get the bits to do that, and we'll be back in a minute. Okay, so over here is where we are. I have my little board. I have 2 pieces of wire, and I've got the various crimping bits and pieces I need. So the first thing I'm going to do is 2 of these little red spade terminals. I'm going to do those first. So it is just strip a chunk of wire off the end, or the outer plastic rather. As I've mentioned before, I don't really have a proper pair of wire strippers. I did have some of the snazzy automated ones, but they never really worked. So that's that. That goes into there. I use the big crimp tool, which just comes onto here. That, and line it nicely so that crushes that. A little bit of a tug, that's all right. The same with the brown one. It's exciting, this. Actually solving a problem. I've been meaning to build one of these for about 6 months. Pretty much ever since I realised, once I've set the DTC, the DCC++ board up, that I couldn't actually see if the power was on or not. I thought, I need to do this. I thought today, I'm finally going to get around to it. No programming needed, nothing fancy, just straightforward wiring. So that comes off. I now need to strip this end. These are the ends that are going to go now into the board itself. So I'll take the ends off those. These get a different sort of crimp applied to them. I'll strip both while I'm at it. That comes off here like so. And what I need for this is these things. Bootlace ferules, and these are rather good. And some of the tiny little white ones. It's the colour-coded size on these. I've got the crimping tool. Something I've learnt with this layout: don't scrimp on tools. And when you think you're going to spend a couple of £100 on a loco, I mean, some of the locos now about 200, 300 quid. Instead of spending a £5 on the cheapest crimping set you can find, get a proper one. Right, and the other thing I've just realised is, while I've got all these crimping tools and everything over here, what I don't have anywhere near me, because obviously I don't have it anywhere near me, is a screwdriver, which I'm going to need to set this up. So I shall be back in a mo. Okay, back, this time with screwdrivers. So the first thing I'm going to do is find the appropriate screwdriver here for this little board. And I'm going to connect these two wires to it. I'm going to put the blue one in that side. Now, I do need to be sure there's a little bit of a gap here. The reason I need the little bit of a gap is otherwise I'm going to struggle to get the mounting screw in. I'll undo them when I come to mount the screws properly. Be the easiest way of doing that. That can go into there. It screws down nicely. The layout power is off. I have checked this. It's not just normal power off, the full layout power is off. This is my little adapter block that sits on top of this part of the layout. So what I'm going to do is unscrew those. And I'm going to rather unceremoniously add this probably underneath. So if I put that there, that goes in that one, that goes on top. So that's the blue wire. So that gets done back up. And remove the brown wire again. I'll do the same thing with that one. I'll put this wire underneath. Really just down to the way I've done the wires. And the board itself now wants to flip onto its back. So I can see I am going to be undoing the terminal at the other end again in a minute. Just need to try and sort this mess out here. So that then goes into there. And that's now connected to the DCC bus. So like I say, I just need to sort this out. Now if I unscrew that, basically I can take that cable out, let it work out which way round it wants to be, reinsert it, and then do that back up. Right. That should... yes, anyway, we shall see in a second. That should work. So what I'm going to do is I'm going to turn the layout power on. I'm going to make sure there's nothing in the way of the layout power. And then we're going to see if this works. So if I press my wonderful remote control, I can get it to work. That's the layout powered up. Just wait a second for everything to boot up. That powers up the relays. And now I should be able to turn the track power on. And this should light up. Should. Do I have track power? I do have track power. This is not lighting up. So that tells me there might be something wrong. So I need to get my meter and we'll find out. This should work. I'm going to find my little digital meter to find out why it isn't. Nothing's ever simple. AC. So set this here. Should be able to see is that I have power to this, and I do. I should have power across that diode, which I do. Should be able to turn this over and say, what have I got between there and there? A voltage between there and there. What this tells me is the LED's not working, which is slightly annoying. I do have the required voltage across the middle. Right. Let's turn the power off. That. Nothing's hot, which is always a good sign. Let's just check how this diode works. So we shall disconnect this, like so and like so. And this thing has actually got a setting that will test diodes. So if I touch this and this, the thing should light up. One way around or the other. And it doesn't, so that diode doesn't work. Typical. The LED doesn't work, which is slightly frustrating. Okay. Across, yeah, I'll just go. So that wire to that wire, nothing. The other way around, nothing. So the normal diode is working, the LED isn't. So back to the drawing board. I'll be back in a minute. Okay, we're back. Full disclosure time. Let's have a little look, see if I can get this to zoom in. Turn this round. The circuit is correct. The circuit works fine. Would have helped if some moron hadn't soldered the LED in backwards. And it's done various bits of damage on the bottom of the board removing it. If I can get that to focus. Yeah, it's fixed. So let's try once more. You can tell I don't rehearse these things. Right, let's screw that back in. Like that. Like that. You know what, I don't think that needs a mount either for temporary. Right, track power on. Whee! Look at that, we now have a green light. That would have been more impressive if it had been in shot, let's face it. But that tells me the track power is on. So, yeah. And if I come over here and press the magic red button, get this to actually sit flat. It'd be quite useful. Stay there. Yeah. If I turn track power off, light goes off, light comes back on. Now that's useful because I can see that from around the layout. It's not the brightest of LEDs. I have got some really bright green LEDs. They're actually blindingly bright. Don't need it for this, just need a little indicator. So there you are. A little indicator light that says, I now have track power. So, because I've got track power, I'm going to move a train just to prove I've got track power. So I should be back in a mo when I've found a suitable train. Okay, here we are back. The light is on. Now the other thing I've been doing, I say this is not fixed down. This is for some track power experiments. I have done a little bit more wiring. All the joins over there are now soldered up and cut. So these bits of track now are wired up correctly. All three of those work. Trains can drive on them. K3, that works. I've also, I come around here, those joins are done. That little section there up to those next joiners, that is also powered up. That is part of the reverse loop. The bit in the middle isn't wired yet. Yeah, connector block down there that doesn't have any wires to it. So what I'm going to do, now I can drive trains on this little bit here. I'm going to. So I'm going to bring the K3 out and she's going to have a little circulation and we shall see how well she copes. But so we're now onto older bits of track. Tumbling around quite nicely. I was looking earlier this week as well. I got an email about the Acura scale J, whatever it is, J69 I think it is. I was sort of thinking to myself, do I or don't I? Bearing in mind that's about 230 quid. Sound fitted though, so I might. I've said to a few people online, what I'm going to do is I'm going to take a risk. And the risk I'm going to take is that it won't sell out immediately. And I might be able to get one with a bit of a discount later. I could regret that, because that means I might not be able to get one. However, there's something else I'm getting this month, which is not railway related, which is going to be quite expensive, so I'm waiting off. Right, this is the van train. This is on the inner loop, so hopefully it'll work a little bit better. Place your bets, as we're going to try and follow the K3 round on a full circuit. just because I think every video I should do, if I can, should have at least one train moving in it, as long as everything's not in bits to the point I can't. So off we go. Nice nice low speed, which hopefully means things will work fairly reliably. I had to curse it, didn't I? The track around there's, well, I say around there's a bit ropey. The track's ropey everywhere, so there's a bit there where the wheels come off slightly. But now we can go past the little scenic area. Spot what's missing. Yes, I'm going to bring around and hit stop. I'm going to go and find, because I can come around here. I'm going to see which DAPL van it is that derailed. Oh look, it's an Apple van that derailed. You'd never have guessed. I would never have guessed in a million years a DAPL van would have derailed, or its couplings would have failed, or it would have exploded or something. So let's bring her back up. Okay, the whole layout has just gone absolutely bananas and reset itself. There's something about track round there that does that. I don't know what it is. I've had a couple of little electrical problems recently. I'm not entirely sure. So should have connected forwards. Go, try again. Let me just try. Somewhere I've got a problem. Yeah, anyway, I'm going to have to experimenting. So try coming back again. And for whatever reason, these are deciding they are not going to couple up. So I'm going to come around here and have a little look. Strongly suspect, oh look at that, it's the banana van's coupler is pointing in the wrong direction. Right, try again. Yeah. I've got servos chattering somewhere, I can hear them. I do have a new power supply, which I'm going to be trying, which hopefully will work a little bit better. Right, anyway, we're on the move again. Let's see if we can make it back to the yard this time. Past a camera stand, always past a camera stand. Over the points. Lift up a little bit so you can see past things. And it normally works fairly well in this direction. These vans tend to work, so yeah. Not sure why they decided to derail that time. Yeah. The loop is still set. Accelerate a little bit and try again. Again, the Bachmann K3, lovely little loco. Light is still on. She should make it with a bit of luck this time because she's going a bit quicker. Yeah, there we are. There's just a little spot on the rail there where she stalls. And this time all the wagons have worked as well. Woo! See if we can get a loop. Incidentally, I've got some more coaches. Could we do something with some of those soon? Try and make them look a little bit better. Try and put an interior in them and so on and so forth. A bit of paint. We shall just rumble around here, and then this will be it for now. And we stop when we hit that piece there. Go back to normal zoom, so hopefully it's not quite so much seasickness cam. There we go. Now I'm just going to reset a few points. Still got something chattering. I mean, I doubt you can hear that. One of those 2 points. I'm going to try setting the other one and see if it clears it. Silenced again. Right. Yes. There's a little source of an electrical problem. The outer point over there is happy in thrown mode, but not in closed mode. So, yeah. The servos need adjusting, is what that's telling me. I need to fiddle around with the code a little bit more. Those ones over there are an absolute pain to do because they're awkward to get at, because I'll have to clear the yard out and whatever so I can get underneath it. That's a job for another day. I was going to be giving these wagons another try as well with some extra weight in them. That's for another day. Anyway, so today's video was about the building of this. A little indicator thing to show track power. And when I find the appropriate piece of paper, and the thin chance I can find it, I'll bring that over here. What we have is the circuit. We had a little look at how you work out a resistor. I will go into a little bit more detail on this on LEDs. There's quite a bit you can do with them, just on different resistors, different current values, but the maths isn't complicated, which is the key bit. It's nothing to be scared of, and it can be done quite easily. Yeah, so we've sort of seen that. We've seen how to build that incorrectly, and then sort of I've fixed it and I've got it working. A couple of little components. It is fairly straightforward. I probably will make a little 3D print mount for it at some point. I might tidy it up. I may just put that, come up with a little box somewhere that can sit in and just have its little LED poking out going, hello, I'm here. Yes. Anyway, that's that. Hopefully you found that at least slightly useful. Yeah. Anyway, I'll catch you all in the next one. Thank you very much and goodbye.